Greetings, everyone. This is Eric Andelin, Senior Workflow Specialist with SimActive, and you're here for the webinar, How to Improve Your Photogrammetric Workflows. And then at the end of the webinar, we're going to give you a little sneak peek into version 10. So with that, I'd like to introduce my guest, David Alamillo. He is one of our senior photogrammetrists at SimActive. David, say hi.
Hey, hello, guys.
There you are.
Thank you, Eric, for having me here on another session. Appreciate it.
Absolutely. Always good to get the experts in.
Well, it's been quite a busy year, but I'm happy to be here with you today. So
yeah,
thank you for the invite.
I would agree for the viewers and the podcast listeners. It has been a very busy year here at SimActive. Things are going very well. So as we get into this, because I said, we're going to go over some of the things that really it comes from conversations with you and other folks in support where we get common questions and things like that. And so we've kind of built this webinar to kind of walk people through some of the things that we see that, commonly are asked. So the topics we're going to cover are best practices for project setup. And as we do this, David's going to have correlated 3D up on the screen. I'm going to be working with him on that, and we'll go to that here in just a bit. But I always forget to cover the topics, so we're going to cover the topics first. Best practices for project setup, generating high-quality DSMs and DTMs, point clouds and orthomosaics, solutions that we have that might help optimize processing. And then finally, like I said, we're going to highlight the capabilities of Correlated 3D version 9, which we've been going through this year, and give you a sneak peek at what's coming up in version 10. So let's start with best practices. If you want to go ahead and open up Correlated 3D, I'll talk. You run the mouse.
I'll round the mouse for sure. Let's go ahead and get started.
There we go. So awesome. For those of you that are not familiar with the interface, we'll kind of go over that as well. David's got a great little project up here that's a good example. But let's talk about a few things. Now, this year, part of Correlated 3D, we added distributed processing. And David, can you talk a little bit about that and then show them where we find that within the interface?
Sure, absolutely. I think this is one of the main functions that I love about Correlator. We actually did a very nice project with over 20,000 images. And there's the marketing piece, of course, we can put in the links, where I was fortunate enough to work on one part of the distributed processing. We're basically using several nodes, several PCs connected through a network to take tasks that are typically done in Correlator and optimize these, distribute them. And obviously the result of it is faster processing. Really an amazing feature for those heavy months and those large projects. And if we go directly to Correlator, as you guys are seeing it on the screen, to display your different distributed options that you have or different stations that you have available, you simply go to the top hand corner, and this would be the icon that you guys would be clicking. If I click it on, you'll see that bottom corner disappeared. Turn it on. And that will list all your available processing stations that are available to you. In this case, you can see my local, which is ready to use. And then another computer, another PC, another node that is available in the network, which is called O'Keefe. At the moment, it's obviously busy, probably used by one of our colleagues. You would actually see it ready in green, and then you'd simply check the mark, and you would be able to use it for all your different tasks in your DSM generation, your ortho rectification process.
Perfect. So that's a good way to cover the distributed processing. So you can go ahead and flip back over to the other project. So back here, as we look at one of David's local projects, we're going to talk about LAS files. So when we talk about best practices, one of the things I like to bring up is a lot of times timeliness or processing time, more to the point, is where people always ask for, how can we do some time savings here and there? How can we speed things up? Yeah. And we talked about, distributed processing, and that is certainly one way to do it. It will rip through projects if you have the ability to do that. Another way is to import an existing surface. if you allow Correlator 3D or any other image processing software to generate a DSM or DTM surface, that takes time. So the benefit of bringing in a DSM, an existing DSM, be it from LiDAR or from existing data, that's going to save you a lot of time. So we added some LiDAR import tools. Originally, when we first started, you could import one point cloud. Now you can import multiple point clouds. And David, can you kind of give them a little show of that?
Sure, absolutely. As you mentioned, it's an amazing tool. We have customers using the light and left and right, really going in and taking not only a single LAS file but multiple LAS files, and that's really something that it's useful when importing these large files. So what we're going to do is go to File, go to Import, and click on LiDAR LAS files. This will bring up the pop-up screen where we have the options, like you mentioned, to add an individual file or add a folder, which may contain several LAS files in there. Drag and drop your LAS, and we'll take them both. And to that point, we'll simply add the file, and then the two options that you mentioned will create a surface and extract the DM as well as the intensity image from the reference ortho. So that, very, very, very handy tools.
Yeah, and I just want to bring up, not to confuse people. We know that an LAS file is technically, just a series of points that create a ground surface. But understand that Correlator 3D is a raster-based product, so points don't really mean much to us. So we do take that LiDAR point cloud and bring it in, convert it to a raster, which, then again, we also have the ability to take the intensity image and convert that into a raster as well. So now you've got a surface and you've got a reference ortho for your project. So that's great on that part, and we'll get into that a little bit more here in a bit. And then also another step that could be some of your best practices is working via script.
Yeah.
Let's say, for example, this golf course is under construction and they're going to do monthly monitoring of the project. So once you create the project the first time, you can save that as a script and rerun it once you have new imagery just by pointing the data or pointing the script to that directory. So David, show them a little bit about that. We have two options here too. We have, as a power user, you can write scripts, or as the average person, you can go through our automated process and output a script that you can then reuse. So show them a little bit of that.
Sure. And let's start off with the easy option, which is using our automated workflow tool and creating a script. So I'll show you guys. You simply need to go to that third icon in the tool. We'll open it. You'll get all your different profiles that are available to you. As Eric just mentioned, I just processed this project, so I want to go with my settings that I currently have. In order to create that script file, the only thing you'll need to do is, if you guys can see the small checkbox here on the left-hand corner, we'll click it, we'll click Generate Script, and hit Process. And immediately the software will output this SPT file, which basically has all my different options that I've used, constrained camera calibration, constrained EO adjustments, and then my output folders as well. So this is probably the easiest way for you guys to start working in generating your scripts. It really don't have any type of knowledge, and it's very intuitive as far as, I do want to generate a point cloud. It's only one change for off to on. Of course, you can find more options in your C3D manual, but as Eric mentioned, there are other options as well. As you guys are very well versed in Python script, for example, or like to get into scripting, you can use these type of script files to automate your entire workflow. Say you have 3 or 4 processes that you want to run overnight, and you want the correlator to complete one, output, pick on the next folder, output, and keep going on until you finish your entire sets of images. The correlator has the ability to do that automatically. And that's something that, of course, if you would like to learn, we also have training packages that you could talk with any of our sales team, and they can point out to the best available package for you and the sessions, and we will help you set up one project, help you with the scripts, and then obviously automate this as much as we can. That's the name of the game, really. Command prompt is obviously one of the easiest ways to run it, but if you want to run it within the GUI, you can as well. There's an option here in the file section, file, run script, and you can input your script that was generated and pretty much continue with the script. So there's two options there to run your script. And sorry, again, go ahead, Eric.
Yeah, I was gonna say you could go into that existing script, change the directories for your input imagery, and then once you've loaded the imagery in here, you could just, again, like you just showed, you could run that script from within the GUI, and that is certainly a way to speed things up, like I said, because you can daisy chain projects, things like that. So less eyes on the software and more eyes doing other things. And that brings up the last one. So we now have notifications, and maybe show them where the notifications are.
Sure,
when we do that setup. Yeah. So general settings, I believe it is.
File, general settings, and
you might email notifications. So you've already got it set up at the bottom. But that's what it'll do, and you can go ahead and close the screen. What it'll do is send a notification either at completion of the project or at completion of each step, per the script. So that's really nice, when you're running a large project and you just kind of want to make sure that things are going along, you've got to get something done. It's nice to get that notification that, the DSM is done generating and now we're moving on to orthos. So you can kind of keep track of your project that way. The last thing I wanted to add to that was, as a power user, maybe you're part of the crowd that's already walking away from email, and you're starting to use text messaging. There are ways to have your emails forwarded directly to your text. You can look that up with your local provider, but if you just Google how to send emails to my phone via text, you'll find plenty of references on how to do that. So, something else that kind of just is a best practice and will help you get through the processing. So, the next thing we want to talk about is a little bit about, questions that people have had. And one of them, typically, especially when we're working with RTK and PPK, they'll come across a small amount of error. That error is probably consistent, and they're wondering why they're having these issues. And a lot of times it could be just the difference between the ellipsoid height versus geoid height. Kind of give them a little look at that and how we solve for that within Correlator 3D.
To give you guys a little brief example, we're talking mainly about geoid ondulation and the differences between geoids and ellipsoid heights. Sometimes it can get a little confusing, even for guys who've been in this for years, and they update their workflow and get a little challenging on why they have those huge offsets through their data. And I always like to start explaining that throughout the years we have developed, several ellipsoid models of Earth, and that our planet is not a perfect circle. For all those flat earthers out there,
it's beyond flat. It's beyond the circle.
Yep. Yeah, as we get into those discussions, of course, it's not flat either, so it's an ellipsoid, and not perfect. So there's something that I like to highlight, that whenever you import your data in Correlator, this gets us to our very well-known coordinate reference system, which is WGS84, which is just contextualizing, the point on a 3D surface, which in this case it's Earth, and that's where we get our lat and longitude. So when you're importing all your images into Correlator 3D, they're defaulted to lat and long WGS84. And I believe the ellipsoid height we're using is in meters. This is standard whenever you drag and drop your images, import your images in Correlator. Now, what happens when you have orthometric height? What is that? And I like to cover it really quick, which is basically, I have a little screen here. I don't know if you guys can see it right now. And it lists both, right? Which is your geoid, orthometric height. It's the distance between a point and the Earth's surface. And that's basically using local geoids. And most surveyors out there will agree, and they capture their points. They go ahead and get their GCPs or checkpoints using a geoid. And when they come into Correlator, you can see that the drone was actually capturing that altitude and ellipsoid height. And there's a small offset between where the surveyor got their check and where the drone actually is obtaining their height, their GNSS position. So how do we account for this variance? Well, we have several tools now online that you can actually do these calculations fairly easily. Actually, we have one really good one in one of our marketing pieces. I believe it's through NGS.
Yes.
And you might have done that piece, Eric. I think it's one of our RTK workflows. Yes. And of course, we can put the link down for you guys so you can review this. But you would simply take one image, paste the lat and long from that image into the website, and it will calculate that offset. So once we know that offset, let me guide you through Correlator and where you would input this altitude offset to account exactly for this. Let's go ahead and open up the project. And let's go through the setup. We will open a new project, import a camera, import a couple of files here just to get through.
Yeah.
And this is the place where you would input your altitude offset. So let's say we went through this process. We opened up that NGS link. We imported Latin longs. We got an offset of 20. We would input that value in this set and hit continue. And that's the easiest way to account for that offset that we're seeing in between our ground control point, our checkpoints, and typically our imagery collected in ellipsoidal height.
And what that's doing is it is adding or subtracting that value, depending on what the situation is, to your EXIF information, to the altitude that's being reported with the drone. So that's what it's doing to make that correction. And if you weren't to do that and you were to run it RTK, PPK assisted and process out the data set, you'd probably see a consistent vertical error. Anytime you see a consistent vertical error, then you're probably off in your geoid/ellipsoid adjustment. So just to keep that in mind. So that's great. Thank you for that. That's very helpful. And then the other thing while you're there is camera calibration files. So a lot of people ask about that.
Yeah, let's talk about that a little bit. This is something that we get asked a lot, especially for non-metric sensors versus metric sensors. Metric sensors, you have your calibration provided by the manufacturer. The real question is, do we have to copy paste all those values in here, your decentering parameters, radial distortion parameters? And the answer is no. Whenever you basically join Correlator, you can ask for the format we use, which is a .cam file. It's generated within Correlator, but ahead of time, we can provide you with this file, which you can use it at this stage to import it, and it will fill in all the values automatically for you.
Yep.
It's very easy. Just basically get copy paste into this file. You save it in a secure location. It's on your desktop, and you use it every time you want to import your calibration. And you can see it's always defaulted into a .cam or a TXT file. So it's very easy for us to provide you with this format, and all the values would be filled in for you. Now, what happens if you actually do your calibration within Correlator? You can extract this information from the software as well. Save it and use it next time you're creating a new project. And this is something that a lot of customers like to do once they've flown a mission where they had a very well distributed amount of GCPs, and they got great results, great accuracy, and they would then default into say, I like the calibration that was done to the sensor. I want to keep using this for all my future projects.
Yeah. And
now, maybe a question that we always get, Eric, and I know you're the expert on this, is can I keep this calibration for the rest of my life? Will it work forever?
Yeah, the answer to that's no. But you bring up another point that I wanted to point out. There are different calibrations. There are different forms of calibration. We import basically the standard USGS type calibration.
Yes.
Trimble may have a little bit different one. So there's a little bit of conversion that needs to be done when you do import that information. And then there's always lookup tables and things like that, that you could work with. Now, as David said, a lot of this stuff will auto-populate. And when you don't have that high-end camera, you're not going to get, KO through K4. You're not going to get PX and PY or any of those things. You're going to let the software calculate that. But if you bring in a sensor like a phase one, it is going to have all that information. You can bring that information in, and that is really your starting point. That is not your end point, that's your starting point. So if you were to process that data out and you were to see some error, understand that even though it's a fairly tight metric camera, the calibration that it came with was calibrated in a lab. And in the reality, unless you're mapping the inside of a lab, you need an in situ calibration, which is something done in the conditions that you would be flying. So don't be shocked or upset when you see the manufacturer's calibration not providing you the result that you want. That's why we have control, and that's why we always tell people to have control, because you want to let the software find that solution. And then once it does, as David said, it can be reused for a period of time. And if we had the full project open, so you say, for example, you close that camera parameters. And so can you go back to the other project, the golf course project? Yeah. So now if you go up to File and Export, there you have the EO and the camera calibration file. So if you export that, that's going to give you the camera calibration that produced the good results in this project that you probably want to reuse, or at least use as your base the next time around. So, be aware of that. And when it exports it out, it's going to export it out in the same format that we import in. So you could always just reuse it and drop it in. So that was one thing I wanted to go over. And, honestly, that could be a time saver as well. Good, David, thanks for bringing up those two common issues. So now let's look at, and we've covered this a little bit, but let's look at generating high quality DSMs and DTMs, and then point clouds and orthomosaics. So we've already said that if you have the opportunity to bring in a point cloud that's already existing, great, bring it in. It'll come in as a DSM. You may or may not still want to convert that into a DTM. So allow our algorithms to perform the same ground class that you would with LiDAR. It would do the same thing. It would create a ground class. Optionally, if you had a LAS file and you could create, a ground class only LAS file, which you can, you could always import that in, and then you've skipped any processing time on the DTM side. So think about that. Right. Depending on what you're going to map. If you're mapping this golf course, that's probably what you want. If you're mapping, an urban scene, then you probably want that DSM. So just bring in the LiDAR point cloud, all of it, and work from there. So you have those options. And then we covered bringing in multiple LAS files, and we do, because again, we're not primarily a UAV based software, although everything we do applies to UAVs as well. Most of our customers are very, very big mapping firms. So they're flying large format aircraft or satellite or something like that. They're capturing huge projects. So that's where, that's kind of our niche. That's kind of where we really make some movement. And to be able to bring in LAS files at that scale is very important. So that's kind of why we allow the multiple LAS import. That's kind of why we like the distributed processing, to allow that work to be spread out. So, those are two things that I wanted to cover. And then when we go to create the orthos and we go to create the mosaics, let's look at the options that we have when we do that.
Good question, Eric. Yes, and that brings us back to your previous comment of where you're basically generating a DSM within the software. Either you imported a DSM, you generated that from LiDAR, or you have the option to create that next surface, which is your DTM, and extract everything and just leave you with the terrain model. So now that I have these two different raster files, I can pick and choose which one I'm going to use to ortho rectify. So let's open up the tool to ortho rectify here from the top bar. Mm-hmm. And as soon as we load it, you'll see that you're presented with the first option, which is a true ortho. Do you want to run a true ortho? And you can say, and it basically explicitly says DSM based. Means we will use a DSM in this case to ortho rectify and to continue with this step. There are, and I have to say, in most cases, I am using a DTM, and the reason I use a DTM base and not a true ortho in some cases is because how natural a DTM looks. When you're looking over trees, when you're looking over water, it basically renders a very nice and beautiful image. Actually, the one you're seeing underneath the golf course, you can see even with the water and trees, it's a DTM ortho rectified product. So the question is, in some cases, and we work with large firms who do this for production, they're explicitly asking for a DSM, a true ortho, DSM-based ortho. And it's in the specifications of the project. And of course, if you're following to the T exactly what your customer is asking for, you simply turn on your DSM-based ortho and continue the process, obviously giving you the options to do either or.
So let me jump in there a quick second. So here's the problem with a DSM-based ortho, and it's not necessarily a problem, but you have to understand what you're doing. Structures look great, but so do cars, and then trees do not. So if you want to do that, especially in, as you get out to rural areas, you're probably going to want to do some editing on that DSM. You're probably going to want to keep the structures and let the vegetation go, the route of the DTM, which with our editing tools, you can certainly do that. So you've now created a hybrid where you're keeping the structures and then you're using the DTM for the rest. So just be aware of that. If you just go from a fresh DSM and process a true ortho, you're going to have areas in vegetation where you're going to say, this looks like a mess. And that's because it's draping that image over that tree. So it does look like a mess. And then another thing I wanted to point out here, because this was an issue we had the other day with a new customer on overlap. So right now it's telling you that the overlap is 64% over the entire project, the average overlap. And that, I believe, if you hit optimal, go ahead. It's going to tell you that it could work with 30% overlap in this data set. And then go ahead and hit maximal as well. If you hit maximal, it goes back to 64%. Now, in all honesty, if you pressed optimal, it might take a little less time to process those orthos. But your problem is going to be is that when it goes to do seam lines and when it goes to do color balancing, you've restricted it to a small portion of every images. So you don't really want to do that. So always use maximal if you can. And then below that, now when we start talking about large format aircraft, where we talk about the crop percentages, those are left over from the days when you used to have vignetting from cameras inside of aircraft bellies. You could crop, or you could crop out fiducials, things like that. So typically we would not do that unless you were working with a large format camera, then go for it. Or if you notice vignetting from your aircraft. So be aware of that. And then, let's talk about output resolution as well.
That's a big one, especially for, folks who are working with their specific resolution. Sometimes I was mentioning they have a specific resolution they need to output this at, especially for design firms or guys working with CAD, and they need to output this in a certain resolution. It's a great place to start. I know 0.8 will default to our optimal, but that something is too much. It's really an overkill for some folks.
Yes.
And we've been on support calls where they've said, we try to import into CAD and it just crashed my program. What can I do? We go back to the list of specifications like, it needs to be a 0.25. What did I do? And it's very common to make this mistake and again go back and simply do the ortho rectification and adjust the resolution. Or it's something that sometimes you overlook as you're trying to get the fastest processing done. But this is a very good point that you bring up, and it's very common with our CAD guys to they have a specific resolution they need to work with and not necessarily follow the optimal that we have of the software.
Yeah, it's like having a new Corvette. Just because you can go that fast doesn't mean you need to. And it's the same thing with data. Just because you can get to a granular level doesn't mean your customer wants it. So, and that really affects processing time. So, be aware of that when you look at that resolution. And then the last thing down there is the bit depth, depending on the camera you have. If you're working now with phase 1, which we also, updated in version 9, you can now work with phase 1 IIQ, which is their native format, which also happens to be 16-bit. That is great when you're doing the AT portion, and you get a little bit more view in the shadows and things like that when it's doing tie point adjustment. But again, is your customer on the other end using 8-bit or not, 8-bit or 16-bit? They're probably only using 8-bit. So at this point, you may want to say, let's process out in 8-bit these orthos. So that's certainly something that we needed to bring up. And then if you can go ahead.
Sorry, while we're on this page, another thing that I also see a lot is when you're running the automated workflow, we don't include the option to compress. That's not included by default in that automated workflow script that I showed you guys at the beginning. And we certainly can add it. I always send customers this specific line that they can input into their script that it just does this, JPEG and TIFF compression. You would be amazed, Eric, of all the support calls I get where it's like, my hard drive filled up with orthos and I don't know what to do. So it's very common that you get either the software stops working or, your hard drive gets filled up. This option can save your life. Your hard drive will be really happy because you'll definitely save some good space.
So, let's flip over to the Mosaic page.
Sure.
Okay, so here in the Mosaic side, you've got a couple options here as well, and you can go ahead and walk us through what's going on here with the Mosaic page. So go for it.
Sure. One of the important ones is if you have a tile definition file, you can import it at this point. So you have a bound Mosaic area. You want to import that shapefile. I always tell customers they can create shapefiles within Correlator. So they don't necessarily, if they don't have the shapefile or the boundary, they can create it and save it. And I'll show you guys this in a bit, but it's something that comes in very handy as you don't have to go into your GIS software, create your shapefile and drag it in. Or if you have them, it's very cool to crop it, have a bound Mosaic area, tile definition area that you can bring in. So that's option number 1.
Well, let's also not confuse them. The bound Mosaic area is literally that. You're importing a boundary and you're saying you don't need to produce the Mosaic outside of this. So it kind of gets, some people kind of get confused with here tile definition file. They think that it's actually, a tile cut up scheme or something like that. It's not. It's just it's just how we name it a shapefile so that you can create that nice boundary around your property line or something like that.
That's right. And in most cases, a lot of folks do it at the DSM stage, which I always recommend doing it at the DSM stage. Clean up your DSM, and then when you're out to produce your Mosaic, it's already clipped. You already have a bound area, like in this case. So whatever you do at the DSM stage will carry over to the Mosaic creation stage, and you will have this nice boundary already done.
So cover the nadir optimization in the loaded DEM.
Nadir optimization, yes. This is a very handy tool. I use it a lot, especially for a lot of UAV projects. It does help a lot. It does take the best nadir portion of that image and then produces the best results in the Mosaic. I see it also helps a lot with the seamline editing. They're tools that sometimes you overlook because you're just hitting the process and you don't really think about the benefits of it. But I always, especially for large projects, I always decide to include it. I use it myself a lot. And you'll see a warning message for medium and large format sensors. I don't know if you've bumped into this, Eric. There's a lot of folks ask me questions like, why can't I use nadir optimization with a medium format sensor? And it's not recommended. However, I have seen cases, specifically some cases, where the nadir optimization does help in the seam line editing and the processing. So while we do throw a warning message, I've seen folks use it and compare results. This is something that, of course, Correlator gives you the option even to output 2 different Mosaic folders. So at the end of the day, you can compare both options to see which one yield the best results. And sorry, go ahead.
Well, and I was going to say to that point, again, what people need to understand is that when you're working with UAVs, the cameras in general are not quality or not of high quality. Therefore, the nadir optimization is just saying, hey, most likely the best part of this image is towards the center. So let's focus on that. Whereas when you're working with medium and large format, these are calibrated aerial mapping cameras. They are, in most cases, good cameras. The lens quality is great. The lens quality has been mapped. It's known. And therefore, you can use more of that footprint. So that's why the warning comes up. And then, go ahead.
No, I was going to point out the next immediate tool, which is the loaded DTM for seamline obstacle avoidance. As we go into the seamline editing process and how much this helps, it's an invaluable tool. I think this is one of the things that obviously helps a lot. Talking to photogrammetrists, everyone who has to do the photogrammetry in their companies thinks seamlines are the worst part of the entire process. Everyone knows. So this really assists. I would encourage everyone even to do a test if they can when they're using the loaded DEM to do the obstacle avoidance around buildings, around structures, and not use it. And you would immediately see when you go into the editor how much it helps and how much it goes through the object, and it saves your lives. I don't have to do more editing there. So it's a really handy dandy tool, and like I said, these 2 options really are lifesavers within the software.
So now we've got to a point where we've told the software to go ahead and create the Mosaic and all of that stuff, and we've got editing tools, and we've shown you those in other places. But now, for example, let's go to the exporting of the Mosaic. So assuming everything looks good, now we want to export the Mosaic. So we'll go to Export Mosaic, and it'll pull it up. Here now is where you want to deal with tiling schemes and output formats. So, again, we see you'll input the Mosaic folder. You'll decide what your output format is, if there's going to be compression to it. If you had not already done a crop area, you could do it here, which would then crop the Mosaic to that nice property line you imported. And then tiling from file, and then you also have automatic tiling. So I personally recommend tiling from a file because you can set it up in a way that it looks logical and pretty to you, or to the end user. If you just use automatic tiling, then all you're doing is telling the software, hey, start in the lower left or the upper right, I forget which one it is, and start tiling at a given pixel size until you've covered the whole image, and export those tiles. So visually pleasing, they may not be, especially when you're creating like an overall layout map or something like that. So, bring in a shapefile, create a shapefile and bring it in. And, you can also have the naming structure in there, and it'll read that. So it'll tile them 01, 02, or, whatever you want, as opposed to automatic tiling. Now, if you don't do automatic tiling, it's going to create one big single mosaic. And, for the most part, most jobs, that's fine. And then you can, take it out into your software and cut it up all you want. But there's also times where, no, that's going to be way too big. So again, go back to the tiling and tile it out before then. So, but you only do that after you've gone through your seamline editing and you're happy with everything. Because once it's out of Correlator 3D, it's out. So, you really don't have a
Yeah.
lot of options there. So that's the one thing I really wanted to bring up, because we have seen people on occasion miss that step and then wonder why, their seam lines look like this or this and that. Well, did you even did you even edit your seam lines? So you got to be aware of that. So thanks.
That is true.
I wanted to look at that. Um,
No, that's a very good point. Now, you made a great video on it. I think it was you,
yeah,
Eric, who made a nice video on how to, it's QGIS up on the screen and show you step by step how to create your tiling scheme. And I love it. I share it with customers all over the place because I think it's
yeah,
very well made. And, it's for beginners. And even
yeah.
if you're an advanced user, it really helps a lot.
Yeah, and just because I demoed it in QGIS, I mean the process of doing it in Esri or whatever ArcGIS is the same. So
Yeah,
certainly a way to do that. So just
absolutely.
we've done this. I mean, we kind of covered all this stuff as we're doing this quick little demo. So I just wanted to cover some of the things that we came up with over the past year in version 9. So we added distributed processing, and we've covered that. Email notifications all the way to text notifications. We've added that and covered that. LAS
Yes.
files. When we first started, it was LAS or LAZ, but it was only one file.
True.
Now we've got it so that you can add just an entire folder of LAS files. So that's great, and you can bring them in via script. So anytime we add some kind of feature in Correlated 3D, it is available in script. Correlated 3D can be run command line. You can actually run it without ever opening Correlated 3D. So it's interesting. We get questions from people all the time. Well, do you have an API or do you have an API? Can we do this? Can we do that?
Oh, true.
It's command line. You don't need an
Yes.
API. It's
That's right.
straightforward and simple. So we didn't really cover it, but we did add the multispectral MikaSense red edge cameras
Yep.
that we now support. Satellite, we've got some new satellites. Pleiades Neo is one of them that's now included. A big one for us is our relationship with Phase 1. Phase 1 is really knocking it out of the park with medium format cameras and small format cameras. But one of the ways that their cameras provide such quality images is that it captures rapidly. And to capture
True.
rapidly means it has to capture it in 16-bit so that it's got a range to work with. So it's kind of like capturing a raw image. And
Yep.
on their end, this IIQ format is their proprietary compression tool that allows you to work with that. And this year, working with Phase 1, we've added the ability for you to import and work directly with IIQ rather than having to
Yes.
blow those files up to TIFFs, because it's anywhere between 6 to 10 times the file size. So when you're capturing 70,000, 80,000, 100,000 images, you need to be able to work in small format, in small file size
Yes.
versus large file size. And then with that, we've also added the ability to ortho rectify in 16-bit or 8-bit and export out that same way. So you've
Yep.
got those as well. So I think we've also covered the common questions about importing files, LAS, converting them to DEMs and things like that. So manual tie points, when we're doing the AT. So let's talk about a little. When you create tie points in AT, we've got two options. We've got standard and we've got exhaustive. So give them a little bit of advice on that.
Sure. It's a very common question that we get, and it really comes down to the type of project you're working with, right? The nature of the project, what you're mapping, and I have to say that we do get very often demos where we have to do over large forested areas, where of course there's the need to do a more tighter extraction, which in these cases, if there are only trees, forest, vegetation. I would always tell my customers, while in the demo calls, let's do exhaustive. Let's let the software find, the best possible option that we have in this images in order to create those tie points. Now you're seeing in the background all the different tie points that were done on this one. Of course, very simple because it's a golf course, very open area. But when I mentioned those forested areas, there's times when I would use exhaustive, and I recommend using exhaustive as the first option.
Mm-hmm.
Is it always recommended to go with exhaustive right off the bat? No, it's not. So I tell them it's under very specific circumstances. In this case, it's forested areas where it applies very well. And you would even notice if you ran a standard extraction type, you would see several images without any tie points. What typically customers do is they ran a standard and they, I'll do some manual tie points and add them. And they get tired halfway through the process.
Yeah.
And then say, you know what, I'll do exhaustive. And they do exhaustive and they see that it overwrites their manual type points and the work they've done. So I always recommend evaluating your project. If it's, high forested area, not a lot of distinction between the images.
Yeah.
Let's go with exhaustive first and then proceed to do your manual tie points. That way you don't lose any work that you did manually.
Now, the one thing I want to add to that, and actually it's right below your little menu bar right there. When you look at this, you're over water, exhaustives is not going to help you. So,
yes.
If you can look at it and say there's no way there's more tie points in there, then don't bother trying to use the exhaustive to find that. And I've done projects where we're 4 flight lines out into the ocean, and there is no way that the software is going to find common points. It's just not there. But manually, and believe me, it was not a fun exercise, but manually we went and did white caps of waves and did enough to, because we were surveying the vegetation that would no longer be there after the hurricane. It's gone now, so we don't worry about that. But we were surveying the vegetation outside along the coast of West Palm Beach, and that's what we had to do. Yeah. So there are limits to what the software can do as far as standard and exhaustive. So just be aware of that when you start looking at that as an option. Now, what I would say is, if you run into projects where that's a problem, one way to solve that is to fly higher. And if you fly higher, you've got more footprint to work with. Now, obviously with a drone, you've got a ceiling of 400 feet. So now it's time to call your local aerial photographer and have him fly it. You still have the processing tools, so have him fly it, use the software to do the processing. But that's something to be aware of when you deal with this. Also, another question is constrained versus unconstrained in the EO adjustments.
In the bundle adjustments, right? Yes. We have several options there. I know we've done several videos probably. There was one very good that you did covering most of the EO adjustments. I think it was the last one, which I was looking at the different options that we had. And, the first time coming into the software, you want to know what's the easiest way to get a result, how to get excellent results. This is my first project. What should I use? I don't really want to get into the depths of the software. And I have to say that the easiest way and the one recommended, where the software does all the work for you, is using your EO adjustments at full ATN constraint. Yeah. Let the software do all the mathematical calculations. You let them, work with your images and adjust your images. And that would, in most cases, yield the best result, especially if you're unaware of the different things that you have to work, when importing your EOs and working with your EOs. So I would say the best options that you have is letting the software do the work for you. In this case, we have your EOs unconstrained. And then, of course, talking back to the camera calibration file that we imported. Let's say we didn't import a camera calibration, which is most common for all UAVs out there. We'll let the software do that sensor calibration that you and I were talking about earlier. Yep. And of course, on this project now, I have ground control points, but my first run would typically go as is, full ATM constrained, sensor unconstrained. And I typically do an image filtering to remove any other images in there with a high type point residual and hit process. Yep. That is the easiest way to get results. But we get into the questions of what is the constraint method? Like what can actually constrain? And this is, of course, jumps into the EOs and the IMU and the type of sensor that you have. Are you trusting the EO file that you have? It goes back to also the RTK method where you might not be allowing the software to do any movement on the images because you're trusting what's coming out of that sensor, out of the IMU. So in this case, if you don't want us to move at all the images, we'll go with an RTK PPK versus constrained, where you get this little option menu here that I'll pop it up so you guys can see the difference. And here you get your different bundle adjustment parameters, how much uncertainty you have in your X, Y, an omega phi kappa. And then I guess we'll get a little bit later into the bore site calibration options. But this is a little bit of what you can do when you have when you select the constrained method versus letting the software do everything for you. So you can add here the limits of how much you want it to constrain on X, Y, and Z, and omega phi kappa as well in degrees.
Yeah, the way I like to explain it to people is if you're using full AT constrained, that means you've got a high quality IMU, you know, a Novotel or an Aplanix, and you've got quality airborne GPS data, and you've got you know, a bore site already calibration between your sensor and the communication device. So you're trusting that system all the way around. And again, you do have the ability to add uncertainty like you have in here. Now, the difference for RTK PPK assist, you know, we built this for people that, again, are more in the drone world. RTK PPK assist just means that we're going to trust the XYZ position of the drone in the air, but we don't have that IMU. So omega kappa phi, adjust all you want. So that's the difference between the two. And I always like to bring that up. Now, anytime your results come back questionable to you, then our recommendation is, again, always having ground control, our recommendation is to run full AT unconstrained, let the software process it, and you can probably find where the error is, either coming from, you know, full AT constrained. You may have a little bit of variance in your IMU or something like that, but you could probably find that error. So just be aware of that. Bore sighting, when's it necessary?
Good one. And bore sighting, as you were telling me, you know, I see it more often in folks that have like custom systems, not that much on the UAV side of things, but more custom systems. And I always try to explain it as, you know, it's the software determining the rotations of the sensor, the rotational axis of the sensor, and then the rotational axis of the IMU. Basically, a good way of explaining it is, you know, we calculate the distance from the photo center of the camera to the IMU. And of course, those calculations are done within the software. And like I said, I don't see it very often, but I know folks have questions because it comes up because of LiDAR. And LiDAR goes through a different process, of course, and you might be able to explain a little further how it works in LiDAR versus photogrammetry. But this is basically the software computing that error component for the exterior orientation estimates, you know. And it's a tool that you have inside Correlator. Let me go back here to the screen and show you where that option would be. Here you have your EO adjustment, just do bore sight, and review those results. Now, like I said, it's become very popular because of LiDAR and how it's done in LiDAR. And there's obviously software that specialize in calculating that.
Yeah, so I can explain that a little bit. So because I've dealt with LiDAR and mobile and airborne. For LiDAR to be any good, all the corrections have to be made on that LiDAR, forward and backward processing and all of that. So honestly, if you think of it this way, LiDAR, when it's captured, you know, the IMU and airborne GPS is capturing the information, post-processing that data, you start with it's basically, I could explain it this way. It's like a pool noodle. It's this big. Your error is that big. It's obviously bigger, but and then you refine and refine and refine until that becomes a guitar string and it's tight. When that happens, then you can process your LiDAR data, and everything is a nice thin line of information that's very accurate. So that's the LiDAR side of things, and we need that to import it in. But now you're also using cameras installed maybe by a sensor integrator or something like that. Believe me, the priority in their mind is the LiDAR because it has to be good. And as we always say to people, when you're using imagery, you could lose almost everything and still produce a good result out of the imagery. You could lose, you know, your EXIF data could be junk. I mean, there's all kinds of things that you could still photogrammetrically solve for. So A lot of times when people bring in, again, data from a dual sensor system, especially on the drone side, you might run that bore sight just to see, again, what that distance is from the
This
capture
is,
point of the center of the image to the IMU, or to
yeah,
whatever they call the center. And
yeah,
how that comes out is in when you export that EO file, in there will be a little there'll be a little thing, an area of correction that shows you, how far that's moved. But that's
yeah,
really it. And again, on the large format world, they do that as well. They set up a calibration field. They may fly it before a big project. They've got
sure.
a very good defined distribution of control points, so they can validate what they already have. And that's where bore sight calibration would come in. Otherwise, you don't need it. So I just wanted to bring that up because a lot of people say, "Oh, do I check bore sight calibration?"
Oh,
Not
sure.
necessarily.
So,
Not necessarily.
yeah, yeah, especially on the constraint option. Yeah, there we go.
And then, yeah, there you go. And so we've covered pretty much everything. And I'll pop up a couple of slides here that talk a little bit about what's going on here in the future, version 10, which we hope to release Q1 of next year. We've
Hmm.
added a few things. We've redesigned the interface, so it's not a big change. You're not gonna be lost when you get into it. But we've added dark theme mode, light theme mode.
Nice.
Made just physically or visually better, improvements in some of the things that we've added. But
Nice.
also, another big thing is that we've modified how we're generating DSMs natively within Correlator 3D because again, over time we've gotten much faster computers. We've gotten we're GPU based. We now have distributed processing, so we're doing some things in the internals of the DSM generation that's producing, as you can see in the slide, very, very nice DSM surfaces and point clouds. And you're starting to see the point clouds, hold edges, things like that, much better. And then we've also natively added the colorization to the point clouds.
Yes.
Those are just a couple of the things that we're talking about for version 10. Obviously,
Yeah.
stay tuned. We just wanted to get people, a quick look at it. And then, hopefully at Geo Week or, later, right after that in the year, we'll be able to show
Yes.
some of this live. It'll come out, obviously, if you're a user that has licenses and your maintenance is good, you're just automatically going to get upgraded to it. So look forward to that. I know David and I look forward to doing more webinars and talking about it because it's some really exciting stuff. So I'd like to thank David for joining me. I appreciate him being on
No.
board because
Pleasure.
he does field the questions from our customers quite a bit at a higher level than probably I do. So if you had questions during this webinar, we'll get you your answers right away. And a final note, this webinar will be turned into a podcast, sans the visual portion. So if you like podcasts, sign up for them and please share that on social media. David, thanks.
Hey, a pleasure, Eric. Thank you very much for having me.